Okay, we're going to go ahead and begin the next section. It's solving quadratic equations using factoring. And so the first issue, to be clear, is the word solve versus factor. Up until now, all of our problems said factor, which just gave us something like this. And what do? We just factored it. Solve involves an equal sign with some number, some expressions that are equal to each other. These can be solved. We can find a value for x that solves this. This is just simply factor. Okay, what makes this different is the equations we're looking at are quadratic. And by quadratic, we mean that there's going to be an x squared term in the equation, which we solve differently than a linear equation that you should be familiar with. So what we're going to use is this thing called the zero factor property. Okay, and what that is, if I have two expressions, a and b could be numbers, but they could be expressions. If I have a multiplying a b and a equals 0, then what we know mathematically to be true is either a is equal to a 0 or b is equal to a 0. Okay? And using this property, we can now solve quadratic equations, and I'll show you in a minute. Okay, so how do we solve a quadratic? By factoring. So the first thing we have to have is that the equation must be in standard form. And by that, we simply mean that the quadratic, all the non-zero terms must be on one side in the form ax squared plus bx plus c. So the squared term, the x term, and the constant in decreasing order, and it must be set equal to 0. You have to have 0 on one side. Once you have it in this form, then we're going to factor to get it into the form a quantity A times a quantity B is equal to 0. So this is one big reason why we learn to factor. Okay, so then once we have it in that form, then we know that either A is equal to a 0 or B is equal to a 0. So what do? We set each factor up here equal to 0, which has an x in it typically, and then you solve it for that variable. Okay, so let's just look at the example from above. So if we had x squared plus 5x plus 6 equal to 0, it is in standard form, so we do not need to move any terms to get the 0. Okay, then what do? We factor it. Well, x plus 3, x plus 2 multiplies to 6, adds to 5, equals to 0. So here is your a, x plus 3, here is your b, x plus 2. These are factors. They're multiplying each other. If they multiply to be a 0, then we know that this factor has to be equal to a 0, x plus 3, or x plus 2 must be equal to a 0. So once we have it in this form and we're solving this for x, it's a real simple linear equation to solve. Just subtract 3 from both sides, and we get an answer of x is equal to a negative 3. This one, just subtract 2, you get x is equal to negative 2. If you were to substitute a negative 3 in here or a negative 2 in for x, you would find that both of those would equal 0. Okay, so these are the two solutions to that equation. And again, it is an equation. We solve equations. Okay, so from another example from the class notes, and then we'll pause this for a second to let you work on some problems, is right here. So 2x squared plus 3x minus 5 is equal to 0. It is in standard form. If it was not, we would have to move everything to one side to get the 0. And then we factor. Well, again, 2 is here, can't be factored out, no greatest common factor, so the only choice is the AC method. A times C is a negative 10. Looking for factors of negative 10 that add up to a positive 3, so that'd be 5 and a negative 2. So I break 3x into negative 2 plus 5. The order here doesn't matter. I just put the 2 with the 2 and the 5 with the 5. But you'll get the correct answer even if you write these the other way. Factor out the 2x from the first two terms. That gives me an x minus 1. The second two terms, because I'm grouping, right, there's 4 terms. Factor out a 5, gives me an x plus minus 1. These x minus 1s are common factors, so I pull it out. Remaining is 2x plus 5. Now I have a times b is equal to 0. That means that I could set a, or x minus 1, equal to 0, and b, 2x plus 5, equal to 0, and solve it. And what do I get? I get x is equal to a 1 by adding 1 to both sides. Here I subtract 5 from both sides. That puts the negative 5 on the right, then divide by 2. I get x is equal to negative 5 halves. Okay? Now, with that said, I want you to go to your worksheets, your in-class worksheets, and here are some problems. Solving quadratic equations by factoring and the zero product property. Okay. None of these factorizations should be difficult, but note this is in standard form, this is in standard form, this one is not in standard form. You want your x squared term to be positive because you don't want to factor something that leads with a negative. So leave this here, move your 11x and your negative 6 over by adding 11x to both sides. That gets rid of it here. Adding 6 to both sides gets rid of it here. So you end up with 3x squared plus 11x plus 6 is equal to 0. Factor those, solve them,